Okay, so let's start the class today by discussing about the geochemical classification of elements. It's an interesting topic. So now slowly we are moving towards geology, geochemistry. Till now it was mostly like chemistry basics. There are various ways of like classifying elements. So when we were looking into the periodic table, we saw that the different groups had different names and they had like different behaviors. So that was one way of classifying elements of the periodic table. It was the chemical way of classifying the periodic table. So you had like metals, like non-metals, transition metals, lanthanides, actinides, noble gases, halogens, and all. These were also classification of elements, but that was mostly chemical classification of elements. Now we are trying to understand all these elements remain the same, but we are trying to understand the behaviors of all these elements on Earth, maybe in the solar system when Earth was forming or the other planets are forming, things like that. So the really simple first is like the abundance. So abundance, how abundant they are. So that's the very simple way in which you can classify elements. So some elements will be more abundant, some elements will be less abundant. So we call them major elements, call them trace elements. Somewhere in the middle there are minor elements. So anytime you take a rock, because we'll come back to rock because that's where we are getting all these things. Like anytime you get a rock, if the rock has more than 0.4 weight percent, and things will become important to understand weight versus moles. So in problem set 2, you had a little bit of mole concept and stoichiometry, although I did not discuss them in the class. I wanted to, but I couldn't. But I think like you have some idea about mole concept, because if you did not, then you would have come to my office hours. Okay, so you kind of know that, but I'll put like so the exam I will try to make as difficult an exam as I can do over the weekend. So exams, I'll try to make it challenging. But I don't know how much challenging, because of how much time I'll have, depends. So, mole concept, stoichiometry. So there will be some questions on mole concept and stoichiometry. Does like everyone in the class feel kind of confident about mole concept, stoichiometry, or is there any doubt? I can do that in the next class. So because in the next Tuesday we'll discuss what are the different types of questions that I'm expecting. I'll try to keep them more objective type. It's because we'll follow what we did in the assignments. So it's similar to that. You'll feel like there's a similar kind of like an assignment.
Can you go like a review of some of the stuff that's from like Chem 1, like Chem 1 and Chem 2?
Yeah, so yes. So the thing, whatever we did during the 1 month was basically a review of Chem 1, Chem 2, right? Kind of like that. Right. So, huh?
That's so sadly.
Okay. I hope that was helpful. I mean, like, was it like a repeat of many things that you already knew?
Yeah, but I just kind of like, when I leave a class, I like to throw everything I learned in that class away. So I was like, God, I gotta remember stuff from like Chem 1 and Chem 2.
I found your playlist to be really helpful.
Okay. So it is like goes through that, right? So, I mean, in the review class, this is what we'll do. We'll try to make the review class an attempt to help you to score the best in the exams. That's what I'll do. So I'll have a fair bit of idea about like what the types of questions and so I have like a set of things that I want you guys to know by the end of midterm. So I will orient my questions of the midterm so that once you do the take the midterm exam, you know that. So I will not go through the exact questions and things like that. I will obviously like have like a doubt session kind of a course in which if you have any doubts of a particular area, we can take that up, solve some questions. And also, there was this weird PDF that I sent you, right? It had like some class's name, and I'm not telling it here on camera because like that was like when I was saying about like this IIT examination that happens in India. So there are all these coaching institutes. They have all these problem sets that we just use that to practice. So that was one of the practice sets. So I would say just keep it with yourself, practice as much as you can. There are good questions, it's not easy. The thing is you'll have like a set of questions with you. I don't think the questions will be more difficult than that. So if you can practice from that, that puts you in a very good position. But I will have some questions in which I'll definitely try to trick you.
Just 1 and 2, right? We're just looking at homework 1 and 2, basically. Is that the cutoff, or is the cutoff going to be today on what you teach?
Kind of like what I teach today, right? So yeah, the cutoff will be today, not the problem set 2, because that will be very difficult for me to like pose difficult questions. So you'll know like everyone scores. I mean, I want you guys to score really good, but on a very difficult problem set. Okay.
Can we get problem set 2 back? I'm assuming on.
Yeah, I'll get it back on Tuesday. Yes.
Do you know like how many questions you're going to make the exam?
How many questions?
Yeah.
I don't know. How many does sound
We have
fair?
an hour and 15 minutes, so.
So 55 minutes is the 55 to 60 minutes. 55 questions?
I've like, how many?
Well, it depends.
So
I'll let you, if there's calculations, of course, we're going to need more time.
yeah. No, there will be no, because, I mean, you won't need a calculator. I don't want that thing in the first exam. I want you to have like the basics of chemistry dialed in first. The geochemical calculations, that will come in. I'll try to get it in the next part. So yes, I mean, difficult questions, but this will be like all the things that you might just not use a calculator to do that. Yeah, I mean, anywhere between, like I'll probably get 50 questions in 60 minutes or something like that. Right? Okay. I mean, when I say hard questions, it all depends on your preparation. So the preparation is going to be like the difficult. The actual test is not going to be like very difficult, because if you have a good preparation, then you will be able to nail it. So, okay. So we'll do that in Tuesday, and doubt clearing class, kind of like that, and go through some of the important things that I want you guys to take home by the mid-semester kind of a thing. So, okay, we'll do that. So, coming back to this, so there will be, if you take up a rock and find out everything that is there and classify them as, I calculate the weight percentage, okay, not the mole percentage, the weight percentage of that, and if anything is greater than 0.4 weight percent, it's called a major element. Doesn't seem like a lot, but the trick would be here, if you have something like greater than this, many things will, so there will be only, say, silicon and oxygen as the major elements. So that will not make much sense, because most of our Earth is, as we saw this before, was this. Okay, I'll write it here. Iron, oxygen, I have to memorize this. Silicon, sulfur, nickel, calcium and aluminium. Most of the iron is in the core, and it's also for nickel. So this is bulk Earth. So this is bulk Earth. If you take the whole of the Earth and try to find out what is the major, what is the most abundant, this is the most abundant. So iron is the most abundant element in bulk Earth. But things will vary when you have different systems. So this this abundance is very much dependent upon which system are you looking. So are you looking at a rock on the crust, or are you looking into the whole Earth, or are you looking in the atmosphere, or are you looking at an aqueous system? So this is very much system dependent. That means the thing that is major in something might not, in some system might not be the major in some other system. Anywhere in between the minor is like 0.4 to 0.1%. So if you take the silicate, so there is this term called, so this is bulk earth, and there is this term called the bulk silicate, or maybe I'll not confuse you guys. So the crust and the mantle together, they have like this silicate rocks. So bulk earth has like core, and then you have the mantle, and then you have the crust. These two are basically, there are silicate minerals. I will run away from petrology, and petrology is like the rocks because I do not understand that much. So I'll keep my things to like minerals, but sometimes it will be necessary to go to the rocks. But I mean, that's my weak part. I do not understand petrology. So I understand mineralogy, and I'll try to keep geochemistry, mineralogy kind of thing. And when you go to Alan's class or like some petrology class, you might learn petrology there, okay? So minerals, this is basically iron rich. So this is iron plus their alloys. Okay? Silicate. Now, what is the shape of this thing, and what's the hybridization of SiO4 4-? These are the types of questions that will be probably.
Is it a type of lithium?
How did you find out? I mean, it's right.
Because
But many geologists will know this without knowing how did you get it? They will, oh yeah, it's tetrahedral, but why? How did you find it?
Oh, because there's 4 oxygen and there's 1 water.
So what's the N? The N that we were calculating. So it was half times, what's the central atom? Yeah. Silicon, right? So how many outermost electrons? Which group, silicon?
It's 14, so 4.
4. It's carbon, silicon, germanium, tin, lead. So this is 4. So now what do we do? What's the formula?
And then minus 4 or something with the
No, it's 4 plus 4.
Plus the anions minus the cations.
Plus the anion. So plus the anion, anionic charge. There is no cation. But what about the oxygen?
And then it's the last one.
We don't calculate the oxygen. Yeah, we don't include the oxygen. So this is just 4 sp3. This is tetrahedral. So basically minus, 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 minus. This is a complete octet. And Si, the electronegativity difference between Si and O is not that much. Less electronegativity, less delta electronegativity. Okay? So when you have less difference in an electronegativity, you form covalent bonds. Okay? And that is why you were able to find out this whole hybridization business. Because this hybridization is only true for covalent bonds. It's not true for ionic bonds. You cannot use the concepts of hybridization to actually find out structures like this. So this silicate, SiO4 minus is the silicate structure. This is the silicate ion. So this is the silicate ion, okay? So you can have different kinds of silicates, and the different kinds of silicates might, so this is a covalent bond, okay? So this is covalent. But there are certain elements where the electronegativity difference between oxygen and those elements are more. So they form ionic bonds with oxygen. So what are those elements that will form ionic bonds with oxygen? Will they be more non-metallic or metallic to have the electronegativity difference? So oxygen sits this side. So in order to have more electronegativity difference, which side elements should be forming the ionic bonds? Metallic or non-metallic? Metallic, because then you're like separated out from that oxygen. Oxygen, silicon, all of these are in here. So there's not much electronegativity difference. The metals are on this side. So you'll form ionic bonds. So there are elements that will form the oxides, okay? So we'll see about the abundance. The abundance is like one of the simpler parts, okay? So now anything, so for example, I'll come to that. For example, so anything which is greater than 4.48% in like silicate rocks, what can those things be? Like some examples of major elements in your crust. Definitely. And?
Major cations, major anions.
Yes, yeah. So like silicon could be, yeah, sodium.
Magnesium.
Yeah. So similar to that. Now these major elements, they control the properties of the phase in which they are. So if it's a silicate rock, these major elements will control the properties or define the properties of that rock. So they define the properties of the system, whichever system they are. So if you are in core, iron becomes the major, and iron alloys. What are alloys? Alloys are metal, any metal, plus metal solutions. These solutions are homogeneous mixtures. Okay? So you can have alloys of, what are some of the alloys that you know? Steel is an alloy, bronze, brass, those things are alloys that we generally use. Okay? Solder. So all these metal and metal, when they come together and mix in such a way that they form like a homogeneous solution. So just imagine when you have a homogeneous solution like a cold drink, or like a drink like Coke or something like that. So that's like a homogeneous solution. Or sugar dissolved in water, that's a homogeneous solution, because you cannot differentiate the water from the sugar. So it's like homogeneous. But oil and water, they are not homogeneous solutions, because you can actually see those different phases. So just imagine that in a metal, in which you won't be able to like differentiate between, so if iron, bronze is, I think it's copper tin, and brass is copper zinc. So if you take bronze, like an Olympic medalist gets a bronze medal, that in that metal you won't be able to find out copper and tin separately. It's like bronze. It's like one phase. You cannot differentiate between that. Okay. So alloys are that. So your core has iron and iron alloys. Will oxygen and silicon be the major element in core? It won't be, because it's not oxygen or not silicon, but it's basically in the core you will have iron plus some alloy making. We'll see what those are. They can be nickel. What are the other really common alloys that you can think about? The elements. We'll look into that. There are many very complicated looking, which I don't always remember, but if I have it on a list and I'll write it down for you guys to remember, I don't care. The core can be here. The crust, as we were talking, so it has oxygen, silicon, aluminium, all those. So generally, those things that are making oxides. So in here, those things that are making alloys. In the crust, those things that are making oxides. And what are the things that make oxide? There is MgO, CaO, Na2O, Al2O3, things like that. So these are ionic compounds. All these oxide making things. So any metallic oxide, so these are metallic oxides. These are ionic compounds. And these ionic compounds will sit here, 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 and here. So you have a silicate structure, which is covalent in nature. But these oxygen minuses will have all these metal oxides coming and sitting. So you can have magnesium silicates. You can have calcium aluminium silicates, sodium aluminium silicates, all these kinds of.
You'll never have oxygen in trace levels in the core because the subduction zone, the heat will react with the other elements, forming one of these far before it ever gets.
Yeah, oxygen is basically trace in the core.
Just from subduction, right? Would be the only way we would get down there.
But there are other things. Yeah, because because if you want to get into the core, you have to be dense enough to reach there. So all these oxides, if these oxides or silicates are not dense enough, then how will they get inside? But things can sometimes behave very weirdly when you go deep. And why would you think that the weird behave? The pressure. So the pressure changes. So sometimes you can have sulfur in the core. Sometimes you can have silicon in the core, but in trace amounts. Or maybe minor, but not never major. So in the core, the major are iron and iron making the alloys that are making. So metallic. What are basically alloys? Is there metals and metals? So anything that will have a metallic nature can only go there, right? So somewhere in this transition, in the D block, the things that are there in the D block, the platinum might go there. Let's see. Okay. Platinum, metal, palladium, iridium, ruthenium, rhenium, osmium. What's this? What is this?
Is that nitrogen? I can't tell. That's
No, W, it's sorry.
tungsten.
Yes. What's the Latin name? Wolfram. So that's why the W. Which alphabetic, from A to Z, which alphabet doesn't exist on the periodic table?
What letter of the English alphabet?
Yeah.
Is it Q?
I think Q should be there somewhere. Q is there, yes. It's J.
J?
J. There's n-
This needs to discover element 119 in J.
They did?
No, I'm just
Okay.
saying.
Oh, okay.
Like somebody
Yeah.
discovered it.
Yeah. So on dedicated to Jay-Z or something. Have both J and Z.
Jay-Z.
So these are the metals. So these are basically the metals. And where do you think these are? I think all of these are like inner transition metals. These are transition metals. For the crust, so we give them a name, okay? So like, so basically so iron is the main, and then they are forming some kinds of alloys. Like so when you have steel, so you have iron and some amount of carbon in it. Okay, so there is a base metal and there are some additional things, okay? So in here, it's basically iron plus some additions. So we call this thing iron loving, okay? So because all these things are iron loving, and we call this siderophile elements. So sidero, I don't know how, but I've seen this because siderite is FeCO3. So sidero is somehow, probably has some root related to iron in some way that I do not know. Phile just means loving, so like iron loving elements, and they go in the core. It's very it's obvious, okay? So iron is the most, it went to the core because of its density, and there are like other metals that are coming in. But these other metals are not able to if they are in minor amounts, they might, because nickel might be able to transform its properties. But if it's like in trace, they don't transform. They do not control the properties of. So they do not. So if anything is in trace, they do not control the properties. So if there was a more smarter instructor in class, they would have first done this thing and then went to this. But I'm doing this two together. It might seem a little confusing, but it should, because this is one type of classification based on just abundance, and this is basically, it's not the abundance, it's the affinity towards where you're going. It's like is their geochemical reactivity, kind of like that. But these things are not separate. That's what I want you to understand. If you have the crust or the core might have, so the major element, which is the major siderophile on Earth. So iron can also be like a siderophile technically. So that iron is also called like a siderophile. But then you can have a minor siderophile, trace siderophile, something like that. So this is one way of classifying. There is another way of classifying. Okay?
Would it be nickel?
Could be, yeah. I mean, I don't know the exact percentages.